What's going on, you guys? Mr. Allen here. We're about to graph this dope rational function. We got f of x equals 1 over x minus 2 times x plus 1. Woo! It's already in factored form. How nice and convenient. They're not always like that, bro. So, say thank you. Thank you. All right. So let's get after it, shall we? Well, my denominator there gives me my vertical asymptote since there's nothing to cancel with it in my numerator. So right off the bat, I've got x equals, and it's going to be positive 2 for one of them. I'm going to have x equals negative 1 for the other one. And then I will also have myself a horizontal asymptote. We'll talk about that one in just a sec here. All right. So let's graph those vertical asymptotes. So I got 1, 2, and then whee, boom. And then I got negative 1, so 1 right there. Boom. Whee, yay. All right. Vertical asymptotes. We're done with those. It's awesome. It's awesome. Now, let's see here. There's a couple ways to look at your horizontal asymptotes. One is that we didn't shift it up or down on the outside there. And also, if my degree in the numerator is smaller than my degree in the denominator, degree of 2 down here, right? If I were to multiply that out, and a degree of 0 up here, that means it's going to be y equals 0. So there are a couple different ways of looking at that. If I had a number out here, outside the fraction, I'd have to shift this graph up from 0, like if it was plus 3 right here, I'd have to move it up 3, and then I'd have my horizontal asymptote there. But in this case, no shifts. Smaller degree over larger degree, y equals 0. Boom. Let's plot it. Let's plot it up. There we go. Y equals 0. Lovely. All my asymptotes are in place. Now it's time to graph this bad boy, all right? So when it's positive like it is right here, we're going to have a graph over in this section. We are also going to have a section right down here. Now, I think I also want to find my y-intercept, okay? I want to find my y-intercept. It's something that's common with many graphs. So let's see here. How do I find my y-intercept? Well, in any graph, if it has a y-intercept, if it has one, I can just plug in 0 for x. So if I plugged in 0 for x, and I'm going to do that, let's just do that right here. 0, comma. If I plug in 0 here, I'm going to have negative 2 times positive 1. Plug in 0 here, I get negative 2. All right, if you don't believe me, I'll write it out. 0 right there, 0 minus 2, that's going to be negative 2. And then 0 plus 1 is going to be positive 1. So I'm going to have 1 over negative 2 times 1. 1 over negative 2 gives me negative 1/2. And look at that. We are going to be right down here. So here's a tick mark there. There's our 1/2. And we're just going to go ahead and come up. And then come back down here. All right. Beautiful. Next up. I got to get my last section here. And it is going to be right over here. We're still in the very basics of rationals. And you're going to see that common pattern there. Once we start adding some negatives, you have binomials that are squared. Things change up, and we're going to want to test some values over those asymptotes, but this is a very beginner, basic video here. Introduction to rationals. As crazy as it looks. It gets crazier, bro. All right. Let's talk domain and range, shall we? We should talk domain and range, and I'm going to go ahead and close that parenthesis there. That was unsightly. I apologize. All right, domain. So domain, x values, right? Is there anything that x cannot equal? Right, that's usually the most efficient way of going about this. Well, I can't equal negative 1 here, and I can't equal positive 2. So my domain is going to be x cannot equal negative 1 and positive 2. Just going to write it like that. Some people like to do fancy brackets. Some like to say all real numbers except that. I like to be efficient, okay? I like to be efficient. X does not equal negative 1 or 2. That gets the point across, right? I don't need the theatrics of the fancy math. Okay. Range time. Sometimes that type of notation works well for range. Sometimes you're going to want to use like inequalities or interval. But for this particular one, are there any y values we can't have? Whoop! 0 is the only y value that's omitted from this. So I'm going to go ahead and say y cannot equal 0. And that's it for my domain and my range. How about end behavior? Let's talk about end behavior. As x approaches negative infinity, what's f of x doing? What's f of x doing there? Well, let's see here. As I approach negative infinity, as I go this way on the graph, this way, it's getting closer and closer to 0. And as x approaches positive infinity, what's f of x going to do? It's going over here. Whee! It's going to 0 once again. Beautiful. And that end behavior should match up with my horizontal asymptote. Time, okay? Every time. Horizontal asymptotes help us out with that end behavior. That's dope, man. That's dope. Should we do some little asymptote behavior? I think we should do some asymptote stuff, right? This video is just too fun. I don't want to end, man. So let's talk about the asymptotes here. As x approaches as x approaches -1 from the left side, right? That means from the left. So from the left side is over here. I'm going whoop up to positive infinity. So from this side of the asymptote, my graph is shooting up. So that means that f of x, it's a weird looking arrow, f of x approaches positive infinity. Now, as x approaches -1 from the right, what is f of x doing? Well, as I approach it from the right, which is this section of the graph here, what am I doing here? I'm woo! As I get closer to -1 from this side, I'm shooting down to negative infinity. Beautiful. We got one more asymptote, bro. We got one more asymptote. So as x approaches positive 2 this time from the left, well, from the left is in this middle section here. So as I get closer and closer from this side, graph is shooting down. We got then f of x. Wait, why do I have these arrows here? What is this? My goodness, Mr. Allen. My goodness. We don't want those there. That's going to be hard to get rid of on this board. But, you know, whatevs. All right, let's just go ahead and comma. I apologize. All right. F of x, that looks wonderful. F of x approaches, we said negative infinity. Beautiful. There's too much math here to do this, so just deal with it, all right? I apologize. All right, as x approaches 2 from the right side now, whoop, we're going this way, we're shooting up. So we're going to f of x approaches positive infinity. That's dope, man. That's dope. Awesome. Now, as things get a little bit crazy, all right, we're going to do some test values around these asymptotes, man. We'll figure some things out with that. But for now, very consistent graphs. That's why we were able to do it this way. I think that was pretty dope. Again, apologize about that with the arrow. There's no need for extra arrows. That was my fault. All right, you guys have a wonderful and fantastic and dope